In this talk, I will explore how artists and scientists have used different imaging techniques and other narrative devices to make sense of particles in suspension, particularly droplets and aerosols emitted by human sneezes. While I do not have time for a comprehensive review of the literature here, I will say that Timothy Choi and Jerry Z's 2015 paper, Conditioned Suspension, has been extremely informative. In their paper, Choi and Z argue that heterogeneous and unevenly distributed material suspensions, such as air pollution, are a defining condition of this late industrial era. The anthropologists illustrate their arguments by presenting two laboratory scenes. In the first scene, scientists use a wind tunnel to suspend sand in the air. In the second scene, various processes are used to extract volatile compounds from organic materials. Both scenes provide microcosmic examples of suspended matter. So in preparing for this talk, I have attempted a similarly scenographic approach. I follow sneezes, clouds, and sneeze clouds through space and time. It's early January in 1894. We are in Thomas Edison's film studio. A laboratory assistant called Frederick P. Ott sits down in front of a kinetograph. His shiny necktie is tucked into his waistcoat. The look really sets off his walrus moustache. Ott sniffs some tobacco laced with black pepper. The operator of the kinetograph waits in breathless suspense to capture Ott's sneeze. By and by, Ott's facial muscles begin to contort as his nasal passages respond to the irritant material. This conflict is precipitously resolved as Ott's head bobs upward, then lurches forward in a complex coordination of tension and release, a sneeze. The resulting silent black and white film of 45 frames lasts just over 1 second. It is called the Edison Kinetoscopic Record of a Sneeze, or simply Fred Ott's Sneeze. Fred Ott's Sneeze is the earliest surviving motion picture to get a copyright. Fast forward to the early noughties, novelist Lawrence Norfolk and artist Neil White are working on an unusual collaboration with a commercial laboratory called Oxford Lasers. Norfolk and White are attempting to use lasers to recreate Fred Ott's sneeze from over 100 years prior. The idea is that the lasers will illuminate and make visible the droplets emitted by a violent expiration. Of course, Ott's sneeze could never be recreated exactly. It is, Sally O'Reilly critiques in Art Monthly, like ordering a drink. You can never have the same again, just similar. Indeed, an exact comparison between the recorded sneezes would be impossible because they focus on different aspects of sneezing. Edison's laboratory produced a headshot showing a man succumbing to a sneeze reflex, whereas the laser imaging shows only disembodied droplets projected across the frame. Norfolk and White argued that their footage shows the true sneeze. They claim that the original record of a sneeze was paradoxically named because no actual sneeze can be seen in the film, they say. This prompts a question that shall linger throughout this talk. What is a sneeze, anyway? In 2002, Norfolk and White published Ott's Sneeze with Bookworks, a publishing house dedicated to supporting new work by emerging artists. The book design is unique and reflects the cinematographic media used to capture the sneezes. Reductively speaking, Ott's Sneeze is 2 flick books for the price of 1. To the left of each double-page spread, we have a celestial constellation of light reflected by sneeze droplets against a black background. An emergent mist of central globules and distal droplets dramatizes the materiality of the sneeze. Most of us might have felt such matter when it unfortunately lands on us, but you don't often see it, at least not so clearly. Then to the right of this unfolding visualization, we have each of the 45 frames from the 1894 motion picture. Each frame sequentially portrays the afferent and efferent phases of a sneeze, written across Fred Ott's rapidly evolving physiognomy. The images opposite one another in the book are chronologically synchronized to tell the story of a sneeze or the sneeze from 2 different perspectives. And there is accompanying text to commentate on each minute development. This commentary seems to meander, an allusion to the weather forecast on January 7, 1894, cloudy in case you were wondering, is precipitated by descriptions of the emergent spandrel of spray cloud that issues turbulently from the sneezer's nose and mouth. Ott's sneeze is, according to its own documentation processes, an elaborate feat of conceptual art to capture an event that had arguably remained in representational limbo, to quote the authors of the book. Yet about a decade after Ott's sneeze was published, a laboratory at MIT started to use somewhat similar methods to research the human sneeze in a very serious way, as a vector of disease transmission. Lydia Buroiber and her team combined fluid dynamics with epidemiology to visualize and better understand how sneeze droplets travel. Like Norfolk and White, the scientific researchers refer to the outward materiality of sneezes as clouds. To be specific, the ejection is described as a freely evolving turbulent puff cloud. This definition critically allows a conceptualization of the sneeze cloud as a phenomenon with a biophysical momentum that, depending on atmospheric conditions, could carry droplets much further than previous transmission models have predicted. Buroiber further identifies distinctive phases in the lifespan of the sneeze cloud: a gaseous phase, a liquid phase, and a solid phase of residues that might contain pathogens. In her laboratory, a powerful camera captures the spray as it emerges from the upper respiratory tract to form an ephemeral cloud. The test subject's face is in profile. The high frame rate shows the trajectory of droplets as they escape from the nose and mouth. So in a sense, the composition reconciles the perspectives of facial movement, captured by the kinetograph, with the fluid dynamics in Ott's sneeze. When applied to the field of disease transmission, scientific imaging of sneezes is a way of making their emanations visible, as a microcloud and viral vector. The laboratory has to be set up in a specific way, so that the fluid dynamics of sneezes can be made visible. Clouds are fleeting things, and sneeze clouds are relatively short-lived. Traces of aerosols and residue are left behind, but these traces are adrift, hard to locate, hard to attach to a source. Conceivably, then, there are similar challenges to representing, describing, and modelling sneeze clouds as there are to representing, describing, and modelling clouds in the sky. For the remainder of this talk, I will focus on the framing, both conceptually and visually, of sneezes as multi-phased turbulent clouds. What happens when a sneeze is identified as a cloud, and a particular type of cloud at that? In her account of cloud physiognomy, Lorraine Daston explores how the logics of cloud classification are inextricable from those of Linnaean taxonomy, despite the fact that cloud evolution is too swift for the human eye to fix, much less to capture in a net of words and images. Daston observes that cloud evolution resembles the mutability of facial expressions more than the processes of natural selection. And here I am reminded of Fred Ott's contorting visage in the video. To read the sky, then, observers must learn how to isolate and abstract recurrent forms among the dynamics of particulars. And this move towards standardizing cloud names, despite the variability of cloud formations over space and time, testified to a collective effort between meteorologists and landscape artists, as well as people whose livelihoods depended on knowledge of weather patterns. Daston draws our attention to the collective epistemology of cloud classification. Scientists would consult with artists and vice versa to distinguish a cumulus from a cumulonimbus, for example. Photographs, paintings, and metaphors were central to communicating the cloud types in circulation. Daston writes, "When it comes to clouds, art and science face similar challenges of description, how to capture an almost infinite variety and variability." Visualizations of sneeze clouds might be informed by the illustrious history of skyscapes in the arts and related cultural narratives. The rich symbolism of clouds as ethereal as well as ominous is now layered thick with concerns about climate change and related violences, with both explosive and drawn-out reverberations. This segging from clouds as divine judgment towards industrial byproduct harks back to John Ruskin's two-part lecture given in 1884, The Storm Cloud of the 19th Century. Ruskin portentously describes a shift in his affective experiences of clouds in these lectures. He invokes the figure of a nascent plague cloud, merging the language of disease with that of weather. In a similar vein, perhaps one might conceive sneeze clouds as both symptomatic and portentous of conditions that scale. A sneeze becomes part of the weather, and just like the weather, should we start to think of sneeze clouds as politically and culturally configured? After all, in many languages and legends, sneezes create moments for acknowledging powers beyond any one individual's control. Sneezes happen to us. They may take place as part of a healthy nasal rhythm of congestion and decongestion, but they can also be attributed to various combinations of allergenicity, air pollution, and respiratory diseases. A sneeze, it could be argued, may present both a response to and a biological sample of the plumes, mists, and smogs of anthropogenic effluents. Sneezes are also the subject of governance in public health campaigns, physical distancing measures, and PPE requirements, or indeed shortages. In Breathing Matters, Magdalena Gorska writes that coughing and sneezing can beget, and I quote, an intelligibility of intersectional social positioning, where the environmental toxicity is embodied, expelled, and produced corpomaterially, end quote. Here, Gorska is elaborating on Stacey Alamo's notion of transcorporeality. That is, the sneeze or cough reflex makes palpable the material continuum between bodies and their worlds, if only for a moment. A sneeze launches a material assemblage which is already disassembling and dissipating, disconnecting from its source. If it becomes a cloud, if there is no hand or face mask in the way, then it is only distinguishable as such for a matter of seconds and with the right visual setup. As Lorraine Daston holds, cloud descriptions must be brutally reductive. They must frame the phenomenon in both time and space before it mutates into something else entirely. The image works to suspend suspension. In states of suspension, materials and understandings alike become murky, turbid, or misty. Borders blur. The sneeze cloud swirls, it has eddies, and it scoops in ambient air. Like drinks, no two clouds are ever the same again, only similar, which stamps a big ontological question mark over discrete categories in the first place. The multidisciplinary research group Forensic Architecture raised this epistemological problem in their experimental film Cloud Studies, made for the Critical Zones exhibition at ZKM in 2020. The film is essentially about the weaponization of the atmosphere, or what Peter Sloterdijk calls atmoterrorism. Like the MIT lab, Forensic Architecture compare multiple sources and perspectives to infer the origins and consequences of toxic weapon clouds. The filmmakers use video metadata, such as timestamps. They construct narratives through triangulation, developing image recognition softwares, plotting trajectories with geospatial models, or simply counting the number of tear gas plumes within a certain time frame. As Andrew Barry puts it in a forthcoming paper on collective empiricism, forensic architecture make event maps from a myriad of sources. These event maps, Barry presses, are not reliant on human perspectives alone, but on specific materials as witnesses within a broader frame of investigation. And these event maps can make events perceivable as events. One strength to forensic architecture's approach is the ability to perceive details that are otherwise invisible to human eyes, such as methane gas captured via infrared remote sensing. To conclude, while the aims of artists and scientists may differ, their empirical approaches often converge when it comes to visualizing clouds. As Lorraine Daston observes, artists and scientists face similar challenges when it comes to cultivating a shared visual language for describing clouds in the sky. It seems that sneezescapes are not so different from skyscapes, only smaller. These observations are part of broader, ongoing conversations about making sense of the materialities of different atmospheres. As Mark Jackson and Maria Fannin put it, matter speaks, so we need to tool our senses in order to listen. Being sensitive to matter in suspension, in particular, is what Choi and Z suggest. The condition of suspension draws attention to matter in transition, matter in conversation. That which burns, puffs, plumes, fluffs, diffuses, hangs, infiltrates, migrates, condenses, settles to perhaps become reanimated again. As such, suspension studies necessitates specialized imaging techniques and imaginaries that may sometimes be poetic but are, for the most part, politically and ecologically attuned. Entities and events assumed to be formless, All forms previously dismissed as intermediary must be voiced, even the humble sneeze.